And there's nothing to say that we have to stop at functions of two variables, right? So I can also work with functions of three variables, f of x, comma y, comma z. Now, if you start to ask the question, what does that look like graphically? That's a much harder question to answer because now you're living in four space, you're living in four dimensions. And if you're curious about this, look up the shape. In two dimensions, we have a shape with four equal sides. It's called a square. So this is in two space. In three space, if we kind of expand that out, we no longer have a square, we have a cube. So this is three space. If you were to look in four space, you no longer have a cube. Instead, you have what's called a hypercube, which there's really not a great way to visualize it. This is what we use to represent a hypercube, and I'll actually write that down, hypercube. And it's just a super cool shape. If you just Google hypercube and go to the Wikipedia page, just look at a rotation of it, and it looks like it's moving. It's so freaking cool. I think it's awesome. You don't need to know that. I just think it's kind of really cool. But here, we're just going to work with this function f of x, comma y, comma z. We're going to evaluate this at f of negative 2, comma 2, comma 3. So let's see, f of negative 2, comma 2, comma 3. So let's see, I have 2 times x, that's negative 2 squared, minus 3 times x is negative 2, times y is positive 2, plus 3 times z, well, that's 3, plus 1. And then we're just going to evaluate this expression. So here I have 2 times 4. Let's see, this will be plus 6 times 2, plus 9 plus 1. This is 8, plus 12, plus over here I'll have 10. This should be 20 plus 10. I should end up with 30. So there's nothing to stop you from saying, okay, what if I had a function of 20 variables, right? Or 26 variables. You use every letter of the alphabet. You could use more than that. You could have a function of 100 variables. And actually, we see weird stuff like that. The higher you go into math, the weirder stuff you see. And you start to see functions of several variables. So I think it's kind of cool, but you may disagree. But for now, we're going to stick to functions of 2 or 3 variables. The last example here for this section, like I said, this is a really short section. Here I want to find g of y, which I'm going to call g of 0, comma y is equal to the function, or excuse me, for the function, and here I have a typo, g of x, comma y is equal to 2x squared minus 7xy plus 3y squared minus 10. So when we look at g of 0, comma y, hopefully we can kind of guess what we're going to be doing. I'm going to take 0, I'm going to plug that in for my x value, and y I'm actually going to leave alone. I'm not going to change that y value in any way. So I'm going to say 2 times 0 squared minus 7 times x is 0 times y, I'm just going to leave that as y, plus 3y squared minus 10. So in this case, 2 times 0 squared, this would be 0. Negative 7 times 0 times y, that's going to be 0. I should just be left with 3y squared minus 10. We can also do other kind of unique things with these functions of 2 variables. So I might say, hey, I want to find g of y, comma y. And this means, hey, take y, plug that in for your x value. So let's actually see what that would look like, just because I think it's a neat question. Here, let's see, 2 times y squared minus 7 times x, which I'm going to plug in y, times y, plus 3y squared minus 10. So I have 2y squared minus 7y squared plus 3y squared minus 10. The only thing I have left to do is combine my like terms. So let's see, 2 minus 7 would be negative 5, plus 3 I'd have negative 2y squared minus 10. So you can do some neat stuff with functions of several variables, things that we're perhaps not used to seeing